welcome to our review on the Group 7 elements. So Group 7 then, if we look at our periodic tables, we find on the right hand side, so it's just the second column in from the right in fact. Now Group 7 have got an alternative name and they're known as the halogens. So if you look at your periodic tables, you can see that we've got 5 of them there: fluorine, chlorine, bromine, iodine and astatine. And again, because you get a periodic table in your exam paper on the very back page, you don't have to memorise the chemicals that are present. You just need to know how to find them on that periodic table. One thing to bear in mind is when we're talking about any of these halogens, then they're always found as pairs of atoms. So you'll find that they go around as Cl2 or Br2. So just remember that they always occur as an atom pair. Okay? We need to know what these halogens are used for. So the first one we need to know about its uses is chlorine. Now you will know chlorine because anytime you get into a swimming pool, that's what's stopping you getting covered in various bacteria. So what we do is we actually use chlorine to sterilise tap water and swimming pool water, and it does this by killing the bacteria that's present. Second use for our chlorine then is for making things. So we'll be able to make pesticides and PVC, which is a type of plastic, just through using our chlorine. The other one we need to know the use of is iodine. Now iodine is going to be used as an antiseptic. So if you've got a wound or pre-surgery, they can use iodine there to kill any bacteria again, and that will then sterilise the wound, making sure people don't get infections. When we think about our halogens then, what we'll find is that we get 2 distinctive patterns that we need to remember. First of all, as we go down the group, they change from gas at the top down to solids as we get to the bottom. So if we think about chlorine, it's a gas, bromine is a liquid, and iodine is a solid. If we then think about the colours, we notice they actually get darker in colour as we go down the group. So chlorine is a green colour, bromine is orange, and iodine is grey. So do remember the different states and colours of those 3 at room temperature. So chlorine is a green gas, bromine an orange liquid, and iodine the grey solid. And then those 2 patterns associated with it. So they go from gas to solid as you go down the group, and they get darker in colour as we go down the group. They might ask you to look at information in a table or in a graph about these halogens and then predict other properties that we haven't looked at specifically. So they might give you something like this graph here to do with the melting and boiling points of all the different halogens, and as you can see there are 2 missing bars there, okay, one for fluorine, one for astatine, and then they'll ask you to predict what you think the value is likely to be. So all you need to do here is just look at the fact that obviously we can see there is a very clear pattern that they're increasing as we go from fluorine to astatine. So you just pick a logical number, okay, and that will then get you those marks. As long as obviously your melting point that's missing for fluorine is lower than -101, then that's fine. And then for astatine, as long as your boiling point is higher than 184, then you'll get the marks there. The reaction we need to know about for our halogens then is their reaction with the group 1 alkali metals. So we've got the general word equation for what's happening at the top there. So we've got our metal plus the halogen makes a metal halide. So if I give you an example, that would be sodium plus chlorine makes sodium chloride. Now do notice the fact that when we're talking about the halogen, first of all just in its raw state, then they end in INE. However, once they've reacted with the metal to make the metal halide, then they end in IDE. And that's true for all of them. It doesn't matter which halogen we're talking about. When they're just a halogen on their own, they always end in INE. But when they've reacted with the metal, their ending is always IDE. So do go careful not to write the wrong letter in there and then lose your mark. Now what we find is that all of our halogens then are going to react in a similar way to each other, because in that outer shell they have 7 electrons because they're in group 7. So remember, whatever group number they're in tells us how many electrons there are in the outer shell, and if they've all got the same number of electrons in the outer shell, then they're all going to behave in a similar way. So finally what we need to look at then is just the balance symbol equation for this reaction. So our M just stands for our metal, and X is our halogen. So remember, our halogens always go around as a pair, so it's going to be X2. And then because we end up with obviously one of the metal atoms reacting with one of our halogen atoms, then what we end up with is 2M plus X2 makes 2MX. Or to put that into actual chemical symbols for you, if we look at the reaction of sodium and chlorine, it'd be 2Na plus Cl2 makes 2NaCl. And it follows exactly the same pattern for whichever halogen and whichever metal we're looking at if it's an alkali metal, because obviously they react in the same way because they've got the same number of electrons in their outer shells.